today I'll be talking about MRI. MRI stands for magnetic resonance imaging. It's an imaging technique that uses radio waves and heavy magnets to take pictures of inside the body without using radiation. It's extremely helpful in taking pictures of soft tissues such as the brain, muscles, and organs. There are 6 scientific hows and the physics behind MRI, and later I'll go into what happens inside an MRI machine once a person's inside the body. The human body is made out of 30 to 40 trillion cells, and it's also made out of water, carbohydrates, and proteins. This brings me to my next question, because all of these have one thing in common, which is called the hydrogen. How do hydrogens actually become protons? Water is the biggest contributor to the hydrogen count, since the body is made out of 60% water. So since the electronegativity of the oxygen is higher than that of hydrogen, hydrogens act as a proton inside the body. So, how do protons actually become tiny magnets? A proton has an electric charge, plus it spins, and the spinning creates momentum and magnetism. This is a direct consequence of Maxwell's law, which basically says spinning charge equals moving charge, which basically equals electric current and a magnetic field. How do protons stay in 2 energy states? In a proton, it's only allowed 2 energy states, which is a low energy state and a high energy state. And as for quantum mechanics, the low energy state is the spin plus half, and the high energy state is the spin negative half. The low energy proton count is higher than the high energy proton count, which directly influences the MRI. So next question on how to give energy to protons. Protons are like wobbling spinning tops in this copper session. After we apply the magnetic strength, protons align, and the radio waves at same precision frequency are applied. The proton absorb the energy and they flip. When the radio waves go off, protons relax back to their alignment, and the signal emission releases energy, which is basically the MRI signal. And how to match precision frequency. Lermor frequency says omega equals diamagnetic ratio times the magnetic field strength. And when we use it in a real world equation, gamma for hydrogen equals 42.57 megahertz per Tesla, and when we put the equations in according to this, we get 63.865 megahertz. Before a person goes inside an MRI tunnel, the protons are randomly aligned. However, once you go inside with the 1.5 Tesla, which is 30,000 times more than the Earth's magnetic field, it becomes perfectly aligned along the magnetic field. Once the radio frequency is turned on to 63.865 megahertz, it tilts 90 degrees. And then after it turns off, it goes back to its normal stable state and releases energy. In the case of a human brain, when there's a tumor, the tumor cells have more water, which has more protons. It takes more time to come back to its release state. And so the computer uses Fourier transform to convert the MRI signal from time to space into frequency. It determines where the signal comes from, it releases energy, and then it builds the MRI image. Thank you so much.